Welcome to our live training session number 14, part 3. In this video, we're going to get our engine tuned on the VPM1 as well as the VPM5 and see what kind of power we are going to make. So without further wait, let's jump into our live training session so we can get started. So welcome back here to our live training with our all-motor B series using Hondata s300. In the last video, we tuned this to about 258, 260 horsepower using VP C85 fuel, which is going to be a race-blended ethanol, which is essentially E85 with some additives in it that make more power than standard E85. So at this point, we're ready to tune this now on M1 methanol. This is going to be pure methanol. So this actually has two different fuel systems in it. It has the main fuel tank. The main fuel tank is going to be, has the C85, it has an in-tank pump, it has lines that are ran up to the rail and the regulator. Now it also has a front fuel cell, so it's able to switch between these two fuel types whenever we like. We have to switch the lines. We can see coming up on the screen here, I have a new feed line and a new return line that I have to hook onto the regulator that go into the cell and to the fuel pump on that front cell. I also have a switch here on my lower left-hand side that I can turn on that fuel pump to be able to activate it and be able to run it. So at any point in time, I'm able to either run my fuel cell with the M1 fuel or my C85. I just have to pull over and switch the lines around in order to configure it, but it's going to be relatively seamless. Now I have to also switch the tunes. The tune is going to be completely different, and that's what we're going to be creating right here. M1 methanol is going to be needing way more fuel supply compared to C85. Now if we pull up the data log from our last session here, we can see if we jump into our fuel graph, we can see that at the top of the run here at 9,000, we're seeing about 61% duty cycle. So our fuel usage hitting our target lambda 0.86 was about 60 to 61% duty cycle. Now with the M1, we're going to be using more. I also have VPM5 sitting here that has its M1 with nitromethane blended into it, so it's going to make even more power. But I wanted to kind of step between C85 or E85, then jump into M1 and then see what it makes. And then if we have enough fuel, we'll put in M5 because M5 is going to need even more fuel. So the first thing I'm going to do here, because I know I'm going to be going and running this M1, I'm going to jump into my parameters. I'm going to be adding more fuel, overall fuel trim. I know right off the bat I'm going to need more. So let's jump into fuel trim. We currently have it at 45%, and that was with the C85. I'm going to jump in here. I'm going to just change this to 60%. I'm going to say 60% fuel, so another 15% on the overall main multiplier across everything in order to get everything back in line. And then when we fire it up, we'll see where we're at. We're going to have to be adjusting everything. We're going to be paying attention to our lambda overlay here, what it's showing us, and our differences. So we're going to be just making our adjustments. Now, we are tuning in lambda, not an air fuel. It's going to be the same concept of working with air fuel, except now between fuel changes, I don't need to worry about what my new stoichiometric point is going to be. My stoich point on M1 methanol is 6.5 to 1. My stoich point on E85 is going to be approximately 9.8 to 1. So there's a large difference right there between the two stoich points, which is why we need more fuel. The richer the stoich point needs to be for a particular fuel, the more fuel we need to deliver through the injector and the fuel system to be able to get to that stoichiometric point. So what I'm going to do real quick here, we can see that our target lambda in our target lambda